Hello, this is Roberto and this is the HVAC, it's my channel. Today we're going to be talking about Condominum Part 14 and Design CFM. And also we're going to continue with the previous video. It was becoming longer and longer, which is not a good idea. Okay, so let's continue and let's pick up from the previous video. So this is where we were left off. When we were left off was in the electrical strip. So the electric strip is from Amana and my model is HKSCO8XC. 8, which in this case is 8 kilowatts. So you don't need performance in this case. You only have 8 kilowatts. So that's why what you're gonna do is in here it says detailed performance and it says capacity. Under capacity, these numbers are in blue. In order to edit those, you just have to press F8. Under F8, input we could put kilowatts, it's gonna be 8. All right, once you hit 8, you're gonna hit apply and there we go. We already have the input, we already entered the electric strip. Okay, electrical strip information. And as you remember from the performance, we only needed the sensible latent, so we have the total and heating based on AHRI conditions. Okay, but now let's make this a little bit more complete. The reason is, and the issue is that we don't have performance automatic population in Wrightsoft database, right? So that's why we're doing it all one by one and by hand, kind of, right? All right, so now in here we have the heat pump unit, right? Split ASHP, air source heat pump, okay? So for the heat pump, we're gonna fill out this data very quickly, okay? So for this data, you have detailed performance. On the top part, you have heating. On the bottom part, you have cooling. So what do we have for heating? For heating, we have heating COP at 47 from the previous video. What was at 47? As you remember from 47 was, actually we can see that in here, 23,200. 23,200. There we go at 47. That's the input that we have. Now we need to get what, so this data is about the BTUs per hour, 23,200, right? So just to make sure that we understand this, we go back to the cut sheet. In the cut sheet, I have for my model number, outdoor unit and indoor unit, we have at 47 degrees outdoor ambient temperature. We have an MBH of 23.2 times 1,000, right? So 23.2 MBH or 23,200 BTUs per hour. And this gray area or this highlighted area is based on AHRI conditions, as you can see in here. Shaded, let's go, shaded area is AHRI rating conditions at 47 degrees outdoor ambient temperature. All right, and the calculations are based on nominal CFM and 70 degrees indoor, but mainly at 47, right? So since we have 47, we're all good in this case for our, in our case. For heating, we're all good. For heating from the heat pump, auxiliary heating is different, right? So this is from the heat pump. Now we're gonna go for the cooling. This cooling is very interesting. Do you remember the AHRI conditions? Okay, the capacity depends on conditions, either design conditions or AHRI conditions or ACA conditions. In this case, we took the capacity for AHRI conditions, which is at 95 degrees Fahrenheit. Okay, so at 95 degrees Fahrenheit, what is my temperature? I mean my capacity. So in here it says BTUs per hour and then it says sensible. So what is my BTUs per hour at 95 degrees? So we're gonna go back again to the table. In the table, we're gonna go up and I'm gonna look for my unit, okay? And which table is this? This is the table that indicates performance data of the heat pump unit. Okay, so since we go to this table, we have this data. See, this is my model number of my outdoor unit, and this is the model number of my indoor unit, right? So in here it says cooling, expanded cooling data. Okay, so for the expanded cooling data, we have MBH 22.2 MBH at 95 degrees Fahrenheit. See, 95 degrees, 22,200. We're gonna go here at 95 degrees, 22,200. We can also have at 82 or 68. Let's go for 82 and let's go check what they have. They don't have it at 82 in here, right? So if you want to find out that number, you would have to make an interpolation process. Okay, but with that, that's enough. In this case, this is just for annotation. It's not going to affect your calculation. Okay, the calculation is this part actually, the performance, right? So this is just, you are including more data, more information. Alrighty, so now let's go in here. Let's continue with the heating. With the heating, you have BTUs hour, which is the capacity at 47 design conditions, AHRI conditions. The COP also depends on your conditions. Okay, so what's the COP at 47 degrees Fahrenheit? Okay, but since we're at 47 degrees Fahrenheit, so what is the COP? We're gonna go check in the table. Okay, hopefully we have that data. If not, we're gonna be able to find it contacting the representative or just finding it in the internet. Okay, so usually the manufacturers put all the information in the internet. Okay, so in here we have the following. What is the COP? At 47, the COP coefficient of performance is 3.4. That's the performance coefficient of performance, right? Okay, but as you may see, when the temperature goes down, for example, 30 degrees, the COP goes down 2.48. And if it's very cold outside, see, like for example, 0 degrees outside, look at the COP is 1.40. So it continues going down and down and down. So the COP in this case is going to be 3.40. So we're going to put that in here, 3.40 right here. Again, this is just for annotation, okay? And what about the 95 degrees and then my EER? We don't have the EER information in our case because as you can see, we're gonna go to the performance table and let's check on any. So in here, you don't have the EER at all. See, you have MBH, sensible heat ratio, delta T, kilowatts, amperage, high, low pressures. So well, let's go to the specifications themselves. In here, you don't have either your EER or SEER number or SEER2 number. You don't have it. But you can always, let's double check in here. Actually, you have it in here. You can put this overall SEER2. See, it's 17.2. Okay? But in this case, you don't have it at 95 degrees. So we can just leave it 0 in this case. But for here it says ratings, right? If it says ratings, you have your HSPF, which is the efficiency for in heating. So in heating, what do you have? In heating, you have a 8.6. In here, 8.6. And then for SEER, you have, what do you have for SEER? 17.2. 17.2 right here. And remember, this HSPF is 2 and then the SEER is 2. It's SEER2 rating, HSPF rating. Okay, but if you want to put that detail, there is always places where you can put those notes. These are based on those notes, on the current efficiency. All right, so now we populated everything. You're gonna hit apply and then you're gonna hit OK. Okay, so now let's go make another review. I'm gonna close this out and then we're gonna put in here. Oh, let's double check again on manual S. What does it say? So in order to check manual S, you go to the preview. Under preview equipment, ACA Manual S compliance report. It's gonna show you only that page. In that page you can make it bigger. See, it's a preview, right? There we go. So for cooling equipment, you have your total capacity of 120%, which is complying with ACA Manual S, as we saw in the previous video. For heating equipment, you have your heat pump itself. It's 106 of the load, 106% of the load. But in Manual S, you want to make sure that your heating strip is not past 175% sizing. So in this case, we have 125% of the load. So it's perfect, because let's be honest, if you put a bigger electrical strip, then you're wasting more money because it's electricity. It's a lot of kilowatts. You can put a 10 kilowatt, 15 kilowatt, 20 kilowatt. So 15 kilowatts, if it's not needed, it's just a waste of money. So you want to make sure that you're within the parameters. All right. So let's go again. Let's go here. Now almost we're done in this case, but now we're going to go for the CFM. So, okay, in my system, I need to put my CFM. So what's my CFM? This is my target CFM. However, now that I have my equipment, where does this CFM come from? Where does the CFM come from for ductwork design, for ductwork? So it comes directly not from the outdoor unit. It comes from the indoor unit, which is my air handler, because the blower is in the indoor unit, right? So what we're going to do is we're going to go to the indoor unit model number, which is the air handler. And then we're going to find out in here, air handler indoor. There we go. So from the air handler indoor, you have this airflow rate, which is the blower data. From the blower data, we have in here the following. So in this blower data, since you have the model number, you have this CFM at 0.5 inches of water gauge or water column. So at 0.5 you have 800, at 0.7 you have 800. This is a variable speed. So for our model number, we're gonna get 800 anyways. See, 800 for each static pressure. Okay. So what I'm gonna do in here is I'm gonna put, instead of this, press F8 to override. So we're gonna put 800 in here, which is not the target. Now it's my design CFM. There we go. And we're gonna hit OK. Perfect. So now we're almost ready to go. And we're going to fill out my blower data. In my blower data, because this is a preparation for my Manual S, this is not showing yet. Why is not showing? We're gonna double check in here. Okay, we didn't put in here the static pressure. Okay. So under the static pressure in here, what was this 800 CFM? It doesn't matter. We can put it at 1.5 inches of water column, because at any case you have 800 for 0.5 inches of water gauge, 800 for 0.6 water gauge, 800 for 0.7 inches of water column or water gauge. All right. So 800 we're putting at 0.5. However, it's interesting. In here, the manufacturer is indicating the chart is for information only, but for satisfactory operation, external static pressure must not exceed 0.5 inches of water column. So in other words, we're gonna put in here 0.5. That's the average, but sometimes we have to extend it until 0.7 because sometimes there is more restriction on the coil, the pressure drop, or the filter. So we'll see how it goes. Let's start with 0.5. Okay, so under 0.5, since we have that, we have this information for the blower. So in the blower, we're starting with the static pressure. The coil usually is 0.22. Let's put 1.20 in this case. Sometimes it's 0.23. That's another process, but we're just estimating an average. Heat exchanger is 0. Sometimes this heat exchanger for furnaces, they have this pressure drop included already. So that's why you put 0. Now supply diffusers, as usual, 0.03. Return grills, 0.03. Filter, we're going to put a 0.10. Not really, 0.15. this filter has a pressure drop, pressure loss depending on the MERV. If it's MERV 13, it has more, more pressure drop than a MERV 8. So this mainly depends on the filter. Okay, and also you don't have to have your filter clogged, otherwise it's going to increase the pressure loss. Balancing damper as usual 0.03. Okay, my available static pressure is 0.06, which is very low actually. So that's why we might have to increase this to 0.7, but we'll see. Okay, so finally this is the last part, and then in the next video we're going to be sizing already my ducts and doing the duct layout. We're going to go here to the zone. In the zone we have the ventilation array 62.2 2010. Now since this is 2010, let's see what the code says. Number one, for the code you need to know your location. This is located mainly in Virginia, in Fairfax County. So if that's the case, what we're gonna do is we're gonna check in the internet what is the code. All right, so in other videos we saw the way we can do that. So we're gonna go to Google, we're gonna put app codes, because we need to know which array is it gonna be. Is it array 62.2 2010, 2013, 2016? Which array is it? We're gonna go for app codes Virginia. Okay, if we go to app codes Virginia building codes, and if you're in Florida, the same thing in California, Tennessee, anywhere, find this code. App codes is very easy way to do. So in Virginia building codes, you're gonna hit here, and Virginia building codes, what is the international mechanical code? So in here it says Virginia mechanical code 2018. So 2018 is the current one, right? So this 2018 is based on IMC 2018. Okay, so we're gonna hit that. This is Virginia mechanical code 2018. So in 2018, we're gonna go to reference standards, chapter 15. Under chapter 15, you have all the standards. See, ACA, Manual D, 2016, AHRI, we have array. In array, we have ventilation. So the ventilation standard, not code, array standard, says they are adopting the array 62.1 2016, but 60.1 is for commercial, non-residential, but we're just gonna assume it's 2016 for 62.2 residential. Okay, all right, so we have the code in here. It says array 62.2 2010 negative, we need the 16. There we go. So for the 16, our ventilation CFM has increased, so my tonnage is 1.9 tons. So our tonnage right now is a 2-ton unit. So far we're all good. All right, so I hope you enjoyed this video, and leave any comment, and don't forget to hit the like button and subscribe. All right, thanks so much. I'll see you in the next video, and get ready for ductwork and duct design. All right, thank you.